The Earth's oceans are beautiful natural resources that have intrigued man for thousands of years. From the majestic waves to the unique and mysterious creatures within. But the oceans are dying. One of the prominent problems facing our oceans today are dead zones. Ocean dead zones are hypoxic areas in the ocean, areas that have low levels of oxygen. The average level of oxygen in the Gulf Coast, for example, is between 6 to 8 parts per million. The dead zones, however, contain 0 to 1 parts per million levels of oxygen. Due to the low amount of oxygen, oftentimes marine life such as crabs, clams, and fish cannot be supported. Since the 1970s, there has been an increase of frequency, more than doubling each decade, of ocean dead zone areas around the globe. For example, in 2004, a study conducted by the UN Environment Program recorded approximately 146 dead zone areas. The largest area estimated at 20,000 miles, all of which could not support aerobic marine life. The total number of dead zone events have since increased. In 2008, a new study reported 405 dead zone locations. Ultimately, the increasing number of dead zone events will result in decreasing amounts of healthy marine life. Resources in the ocean and in the world as a whole exist in a delicate balance. To understand this balance, we must consider the inputs and outputs of resources in the system. In the case of oxygen, it can be introduced to the marine environment in two main ways: photosynthetic life, such as phytoplankton, or direct contact with the atmospheric oxygen. However, it can be removed in many ways, and when more oxygen is removed than is introduced, a dead zone is created. Some natural causes of dead zones are upwelling, underwater volcanoes, and changes in circulation patterns. However, the main cause of dead zones can be attributed to humans. Agricultural runoff from our large fertilized farms causes eutrophication, or an increased concentration of nutrients in a specific area of the ocean. These nutrients, mainly nitrogen and phosphorus, are essential to the propagation of new organisms and, as such, are often the limiting resources, necessary resources that determine the maximum size of populations. An increase in limiting nutrients leads to an increase in population size. When this happens to phytoplankton in the water, it is called an algal bloom. When the phytoplankton die, they sink to the bottom of the water body and decompose aerobically until the oxygen levels are too low to support aerobic decomposition. Eventually, nearly all the dissolved oxygen in the water will be consumed, leaving an anoxic zone behind. Although some rivers deposit nutrient-rich waters into the ocean naturally, soils are not naturally saturated with nutrients in the way they are in modern farms. Increase in use of chemical fertilizers, as well as an increase in average farm sizes, results in a large amount of land laden with nutrients that, when used in excess or shortly before rain, will run into rivers and deposit the nutrients into the ocean, creating dead zones around the mouth of the rivers where they run into the ocean. This is devastating to marine ecosystems. It may be expected that fish would flee this potential suffocation, but they are often quickly rendered unconscious and die. Slow-moving bottom-dwelling creatures like clams, lobsters, and oysters are unable to escape. Unfortunately, these areas also tend to be the same locations that house the bulk of our coastal fishing industry. As you can imagine, dead zones have a large impact on the lives of fishermen. The most notorious dead zone is 22,126 square kilometer region of the Gulf of Mexico, where the Mississippi River dumps high nutrient runoff from its vast drainage basin, which includes the heart of U.S. agriculture in the Midwest. The drainage of these nutrients are affecting important shrimp fishing grounds. This is equivalent to a dead zone the size of New Jersey. Thankfully, dead zones can be reversed. The Black Sea Dead Zone, previously the largest in the world, largely disappeared between 1991 and 2001 after fertilizers became too costly to use, following the collapse of the Soviet Union and the demise of the centrally planned economies in Eastern and Central Europe. Fishing has again become a major economic activity in the region as the newly oxygenated water was able to sustain life again. If we can emulate this activity and intentionally reduce runoff, we may see similar results, which would not only replenish the health of our beautiful oceans, but also reinvigorate the declining fishing industry in these regions.